Welcome to Character Rigging for Beginners Part 2.1. In this tutorial, we're just going to be going over the bind skin tool and all of its options and just really explain what everything does so you know what is going to happen, or a general sense of what's going to happen when you're working with the bind skin tool. So this is the bind skin options that comes up right here. To get to that, you would go to your rigging tab right here and up to skin, and the very first option is bind skin. And if you select the little box next to it, it will pull up this right here. So there's several options in here. I've set a few things in the scene so I can demonstrate a couple things of what they do. So the first option that you have is your bind to option. And under that drop-down list, you're going to see joint hierarchy, selected joints, and object hierarchy. So joint hierarchy means that if I select this joint and then shift select my object and I have that on and I hit apply, it's going to bind this cylinder to all three joints. So they all have influence, even though, I have it on selected joints. I apologize for that. Okay, here, joint hierarchy right here. Okay, click apply. So there we go. Every single joint has influence on it. Because it's all part of this hierarchy. Okay, none of these joints are a part of that hierarchy. They have no influence and no bearing on that object. They have no influence. So go back and undo that. Okay, and we change that to selected joints. Now it's only going to bind to the joint that I have selected. So if I only have one joint selected, it's going to ignore the rest of the hierarchy. If I hit apply, and you'll see that because if I go to a second joint or the third joint, it's not moving. It has no influence. It's 100% on that one joint that I have. Okay. And then the last option is object hierarchy. This allows you to actually bind your object instead of to joints to other Maya nodes like groups and locators and things like that. So, but if you do have joints in that hierarchy of multiple locators, it will bind that joint to it as well. Everything will be included in that. So default is joint hierarchy. So everything that's under it is going to get skinned. Okay, the next option that you have is a bind method. Okay, and it's set to closest distance. Okay, so this is basing the points on the object and how close it is to each of the joints. We'll place the weighting accordingly. So, and then you have the closest in hierarchy. So, if these were parented together, okay, like that, it would look at the hierarchy here of my joints, and it would place it a little more approximately closer to the right space. And so it would kind of avoid putting weight from your left leg over onto your right leg because joint hierarchy is separating them. So that is the closest in hierarchy. And then you have a heat map, which does a fall off from your joint out. and spreads out. So heat this being the center 100%, and then fading off around it. Okay, and then the geodesic voxel method is a fairly new method, and what it's doing is it's creating voxels that is filling up the space of your object. Okay, and according to that and the joints that are inside that, it calculates how it is attaching that. So when we have a very complex model, if we have the geodesic voxel on, it's going to use basically these little cubes to calculate the space. And according to that space and that volume that it takes up is where it's going to be attaching things to. So the resolution of that is this 256 right here at the bottom. And we can increase that for a higher fidelity. So think of if you were going to pixelate this into 8 bits, into an 8-bit image, you would have these large squares of color to define everything, right? As opposed to a 16-bit color where it gets a little bit more. So going from like Nintendo to Super Nintendo, all the way down the line, that's kind of the idea behind voxels. Voxels are really nice because it does give you a pretty decent bind method. So that's what I recommend for your skinning method. For your binding method is the geodesic voxel. And we can turn that up to 512 or 1024. Okay, so those are all the options. The default will be closest distance, and it does okay. And then you have a skinning method. Okay, the skinning method option starts out with a classic linear. So this is pretty normal as to what it does, that you'll see. And what it's doing is how it is calculating the movement of vertices between certain joints and how it's calculating it. So you have 3 options here. You have a classic linear, you'll have a dual quaternion, and you have a weight blended. And the weight blended is just allowing you to paint influence between classic linear and dual quaternion. So it gives you a mix of these two in those orders. So to kind of show you what that does, I'm just going to go to joint hierarchy and shift select this first one and hit apply with the classic linear selected. And because I have a really high resolution, it has a very long period of calculation that is taking place. So we're going to turn that back down here so it's not so big. Okay, so we've got it weighted, and that's kind of what it's giving us here. Yeah, undo that if I don't like it. I'm going to change this back to the 256 for this and apply that. Okay. All right. So you can see as we have these verts that are being shared, it has influence on this joint and on our end joint here. It's starting to pinch it, right? Because it's basing it off of position, where the position of these two are, and it is just trying to calculate in between those two positions where it should be. So at some point, it just pinches off, right? Okay, in contrast to that, we have the dual quaternion. We'll click apply on that. All right, and you can start seeing the difference here. So this one is pinching, and this one, it is keeping the volume all the same. Okay, and the reason why is because it is basing this deformation and how it is calculating the movement of these vertices by rotation of the joint. And so the rotation creates an arc, and so it's going to move everything on that arc. So the volume remains the same. This is really nice because we want volume to remain the same a lot of times, most of the time, if not all the time. The problem that the dual quaternion has is because it works on an arc. Once you get past 180-degree rotation, it doesn't know what to do, and it resets itself. So if you ever have a joint and you're using this and you need to rotate it past 180 degrees, it pops. You can see that pop right there because it's really not designed to go past that 180 degrees. Okay. The other thing that this has issues with is, one, it doesn't like to play well with game engines. Game engines right now don't accept dual quaternion. Maybe that's changed recently, but last I knew it didn't. And then also, it doesn't like scale. You can get some, so this is scaling okay. But you can see when I scale on this different axis, it's giving me some weird results. Right? It's pushing it around in a weird way. And so you can get some really, really negative effects if you ever need to scale your joints. So, which does happen if you're setting up like a stretchy limb system that does base things off of scale. Okay, so that's kind of the difference between those. For the purpose of, the beginner round of things, we're really just going to be using the classic linear for our bind, and we'll get decent results out of that, and we can force it to look really good with our weight painting. Little more work to get it to keep that volume that we're wanting, but it plays better with a lot of other things. So, and then there are those instances where you could be very selective, and you can do the weight blended, and you can decide that you want this joint to be dual quaternion, and you can paint that on these vertices, and then as it gets to the end, you have it painted to 0. So it has no influence on these vertices with the dual quaternion. It goes back to the linear method. And so it just allows you to have both of them on there if you want to. Okay. All right. The next option that you have is your normalized weights. Okay. This is kind of a big deal. If you don't know what normalized weights does, well, I'm going to tell you what it does. Okay, so Maya goes in and it places an influence amount on each vertice. And each vertice, it says, can only have a max influence of 1. Okay, so if you have 3 joints that are all affecting one vertice, it's going to calculate that and divide it up. If we were divided up evenly, it would be 0.33, 0.33, and 0.33 to equal 1. Okay, so basically each of them gets 33% of influence from each of the joints. Okay, and so no matter what you do, no matter how you change those weights, Maya is going to calculate it up to the number 1. You can see this best if you select some joints we're going to go to our tool settings here. We don't need that soft select on. Okay, and you can open up your component display. So under Windows and General Editors, there's a component editor, and I'll go over that in another tutorial. But it does show you one thing underneath the smooth skin tabs. It shows you the total that you have. This is your normalized weight. So the weight distribution on these verts, on this vertex 67, it showed me I have 0.511 on joint 4, 0.485 on joint 2, and 0.005 influence on joint 3. And it's adding it up to level 1, right? So if I set this to 0, this would have 0 influence, and it would push the rest of that influence onto the other joints. Okay, but it is always going to maintain the 0 standing, no matter what I change these two. Change that to 0.8, it's going to keep that. Okay, that is what we want. Okay, that is expected, and it is really easy to plan around that. Okay, and that is what the interactive normal weights will do. No matter what you do, whatever you change, it is going to make sure that that weight only ever reaches a number of 1. Okay, and that is really what you want, like 99% of the time. So, and then the other option is you have post. Okay, post will allow you to paint weights above an influence of 1. So it's no longer going to calculate, and Maya isn't going to say, oh, okay, if this is 0.5 influence on this joint and 0.2 influence on this joint and 0.3 influence on this joint, and then you start painting weights and you start moving it around and adjusting that and adding more influence to this joint, instead of pulling away influence to match the influence you're putting on here so that it equals 1, it's going to add just more weight until it has 100% influence on it. And what that means is when you go and look at it, you'll discover that, oh my goodness, it has a value of 3.5 as its total, or a value of 2.1 or whatever it may be. And when you're trying to get influence, you want to get all these verts being influenced of 100% on this, and you're sitting there painting it, and really because you're on post for your normalized weights, you're not taking away any influence from these joints, from like your elbow and your shoulder joint here. And that gives you, some really unexpected results, because where you think you have 100% influence on here, so by default you say, oh, if this is 100% influence, then these would have 0 influence, and I don't want those to have any influence. But in reality, with the post, you're painting above that, so this could have an influence of 1 on like your wrist joint, and these verts could have an influence of 1 from the elbow joint, and these verts could have an influence of 1 from the shoulder joint. So you would have 100% influence on all 3 joints, totaling up to 3. And it gets really confusing, and it just really doesn't help you out at all. So the reason why the post came about was if you had bound your model, you had your weights all painted, everything was great, and then you needed to add another joint from anywhere. You're just adding another joint, and you need to add influence on that, but you didn't want to mess up your weight painting. They added this post so that you could add in a joint and paint the influence that you wanted without messing up what you had already painted. So if you had like your spine, and then you had a character that had a big belly, and you decided after the fact, after that you had painted all this weight, that you wanted to have some jiggle on that big belly. And so you would put in a joint to facilitate that, and you'd have to add influence onto that, but you really didn't want to mess up all the other joints around it by doing that, and you wanted to add influence on it. That's where the post comes in, where you can add some of that influence without affecting that, and it's going to jiggle and move really well without taking anything away from what you've already done. So that's kind of where some of the history of post comes from, but you really want to be on interactive all the time. Okay? All right. The next option you have is the allow multiple bind poses. So it means exactly that. You're going to allow multiple bind poses, meaning you can bind in one pose, and then you could have a character in a pose and decide that you again want to add more joints, and you could or you need to rebind it to something else. You would have that allow multiple bind poses so that you could keep adding that, and you would get an additional bind pose node added on there. Okay, the next option you have is the max influences, which is set at 5, and that is totally, that usually is great. Every now and then there's an instance where you need that higher, and all that means is that with the max influence set to 5, it means that only 5 joints can ever influence one vertice, okay, at one time. So, and then with the next option, the maintain max influences, if I keep that on and I have a vert being controlled by 5 different joints, and then I paint some weight onto a 6th joint, what it's going to do is it's going to take away any weight that is on it from some other joint, so that it only has 5 influences. So it won't allow you to have 6 influences on there. And then you have remove unused influences. Pretty self-explanatory. And then there's a colorized skeleton here. So as you can see, these skeletons, these joints are just default joints, whereas these joints are colorized. They have a different color. And all it is a visual representation. It has really no bearing on anything. It's just, one, gives you as a user feedback that, hey, these joints have been bound to something. And 2, it kind of has some sense to it. So you'll notice that the parent is an orange color, and then the child is a yellow, and it's the same on this hierarchy here. And it would be like that if all of these were parented all together. So any siblings would have the same color, and then their children would have the next color, in this case kind of a green in there. So yeah, and then you can include hidden selections on creation. So if you had some hidden objects that you were binding to, or that were your bind object, it would ask for it would include them if they're hidden. Maya defaults and says if something isn't visible, then you don't want to use it, and so this kind of overrides that. And then the last option is the fall off, and the fall off is just that, how fast the weight falls off from its heaviest point. So right now it's at 0.2, and I think, yeah, the fall off is only available when you're in the geodesic voxel mode, right, as well as that resolution. So, and that is pretty much it for this tool. So validate voxel state, yeah, is fine. One thing to note, the nice thing about the geodesic voxel is your model doesn't have to be perfect. It doesn't have to be airtight. It can have some weird geometry in there, and it's going to calculate it pretty well. But the one that really doesn't is the heat map. The heat map really requires your model to be pretty perfect. Otherwise, it just doesn't work really well at all. It won't accept it. So, but really for the most part, closest distance, closest in hierarchy, geodesic voxel are really good common ones to use. So, yeah, so that is everything with the bind skin options, what they all mean, what they all do, and hopefully that gives you a really good idea of what to expect. So a good setup for kind of a default thing is just joint hierarchy, bind method, geodesic voxel, skinning method, classic linear, normalized weights is interactive, weight distribution, sorry, the weight distribution, I did miss this one, and I apologize for that. The weight distribution is how, if you were to add influence on a joint that wasn't a part of your bind, then this weight distribution determines how that new object gets weight and influence onto the verts around it. So in this case, it's saying, hey, just from distance. The weight distribution would be from distance. So if I had this joint and this joint affecting this, and then I went in after the fact and I added in this as an influence object to my mesh here, it would calculate and just say, hey, from the distance from here, from the joint out is what it's going to calculate, and it's just going to pull that in. Okay? So, and then you have neighbors. And neighbors just says, hey, what are the values of these verts between all the other joints that are influencing it, and then kind of divide that up and split that up with where the skeleton joint is that I'm adding influence to. So yeah, so this is more for an after the fact. It doesn't really affect your initial bind right away unless you're adding joints after the fact, and this becomes a parameter to kind of know a little bit about. But yeah, that's it. That's everything. So hopefully that gives you a really good understanding of all the bind skin options, what they do, along with what some of them look like when you bind them. So, all right, hope that helps, and good luck.